This is video recording for bonus points 2 for physics, ZPEM 1501. Alright, so here we have my diagram where we've got angle alpha and bravo, and then we've got our tension, so tension going up over the pulley and down. Since M2 is greater than M1, I've got tension going this way and I've got working out later on for question 2 of why that is. So you've got force 2 going down that way and force 1 trying to pull it that way. And we've also got gravity going down and our normals. Now into my workings out for question 1 for working out for T. So expressing T as a function of mass and the angles. So we've got force 1 equals tension minus mass 1 times gravity times sine of angle alpha, and force 2 equals mass 2 times gravity times sine of angle bravo minus tension. The reason I've minus that off, I've minus the mg of tension, and I've got this, is just the way I've got the tension, the force of tension and acceleration working on in my diagram. We know force equals mass times acceleration. Therefore, tension minus m1, mass 1 times gravity times sine alpha equals mass 1 times acceleration 1. So to get acceleration 1, we divide that by mass 1. And we do the same over for 2. So mass 2 times gravity times sine of bravo minus tension equals mass 2 times acceleration 2, which gives us m2 gravity sine bravo minus tension over m2 acceleration 2. What we also know is because they're connected by a rope is acceleration 1 equals acceleration 2, which just equals acceleration. Therefore, we've got the equation, we've got this simultaneous equation. So you can see there tension minus mass 1 gravity sine alpha m1. I won't read out the whole equation, but you can see that they equal the same. If we make them equal 0, so we minus one side from the other, we can then start solving for t, which simple. We use just our equation, start solving it. We pull out common factors. So we make a common denominator. So we want to make this side equal m2 and this side m1 so that we can minus them off each other. So obviously this times by m2 and that time by m1. I'll put the proper maths in there. And then what we get is this formula. And then we start simplifying. So on this side, we start taking out we've got this middle part here, which we can take out because we want t all on one side. So we can add this to the side with 0, this middle part, and what that leaves us with is m2t minus m1t. We've got common factor of t in there, so we take t out, which gives us m2 minus m1, which equals that. And then we can divide that side for t. And then obviously again, just simplifying again, taking out common factors. We've got left with m2 minus m1. That's fine because we know m2 is always greater than m1 from the equation. If it had been m1 minus m2, it would have been an error. So we know it's always going to be a positive value that we're dividing by, and we can never be 0. So that's the big thing. We know it can never be 0. So we've got tension equals that, and G is a constant. So we're allowed to have that in there because it's a constant. So we've got our 2 masses and we've got our 2 angles. So T as a function of masses and angle. So then we'll move on to part 2. So Newton's first law states that our total net force is 0 unless acted upon by an external force. So when net force is 0, acceleration is 0. It's at rest. Well, it's at acceleration 0. So it's either at rest or it's got a constant velocity without changing. a uniform velocity, I should say. Therefore, the absolute value of force 1 minus the absolute value of force 2, or the magnitudes of the forces, equals 0 when they're minused, where mass 2 is greater than mass 1. So I've got to solve this for where they equal 0, but we've got to ensure that the condition meets it where m2 is greater than 1. So I'll move on to the demonstrating that. So we have our what forces. So force 1 we know equals tension minus mass 1 times gravity times sine alpha from our previous working out. And I've minused force 2's, which is mass 2 gravity sine bravo minus tension. And that equals, I've solved it for 0. We can cancel out the t's because they're just minusing off each other. They'll always equal 0 when we minus them off each other. And we're left with negative mass 1, gravity sine alpha, minus mass 2, gravity sine bravo. Taking out the constant gravity. Again, it's a constant, so we can just bring that across here, dividing by 0 by gravity, and if you're dividing something 0 by something, it equals 0. So that's discarded. What we're left with is negative mass 1 sine alpha minus mass 2 sine bravo equals 0. I plus mass 2 sine bravo across. So negative mass sine alpha has to equal mass 2 sine bravo. So what we're saying there is when we're looking at my diagram and that, the force vectors are negative of each other. One side has to be negative of each other. So for them to cancel out, you have to have them going in. You have to have a force vector on the opposite direction. But since we want the magnitudes of force 1 and force 2, we need mass 1 sine alpha equal mass 2 sine bravo. Because that's what we're looking for, is the magnitude. So what I have had to get the rhythm. So therefore, mass 1 sine alpha equals mass 2 sine bravo to find out the force net 0, to have a condition. So that's one condition. The second condition is m2 has to be greater than m1. And so since m2 is greater than m1, we know that m2 equals m1 sine alpha over sine bravo. As I found here, m1 sine alpha equals m2 sine bravo. So to work out m2, we can divide it by m1 sine alpha by sine bravo. So therefore, m1 sine alpha over sine bravo is greater than m1. So with m1 sine alpha greater than m1 sine bravo, we can divide the m1s, and then what we get is sine alpha has to be larger than sine bravo. This is easily observable as m2 is a heavier weight. If the angle is greater than bravo angle is greater than alpha, we know we're going to get constant acceleration because it's going to be pulling down on the weight. Alright, that's my explanation for the bonus point question. Thank you.